We're going to look at being able to graph sine and cosine functions today, and we're going to just do some very beginning graphing. We're not going to delve into all of the extensiveness that we will get into eventually in terms of graphing. But when you graph the sine and cosine functions, it's very important that you know the coordinates for specific radian values. Now, there's an infinite number of radian values or degree values inside a unit circle. We're always starting from 0 radians or 0 degrees, and you can do half a degree, a quarter of a degree. There's so many small increments in here. But we want to be able to graph without our calculator. So what we're going to focus on is we're going to focus on using the radians that fall just on the axes. And the reason why we're going to focus on those is because those are easy 0, 1, or -1 increments. So again, this is the coordinate 1, 0, 0, 1, -1, 0, and 0, -1. And you always want to remember that the first coordinate is your cosine output, and the second is your sine output. So no matter what we evaluate cosine for, we're going to be looking at just the x coordinates. When you evaluate the sine function, you'll be looking at the y coordinates. So what we're going to do today is we're going to basically take this circle and stretch it onto a coordinate graph like we're used to seeing. And so what we're going to do is we're going to make an in-out table. All right, we're going to say, what theta are we looking at? And that's going to be my x or my horizontal value. So input values always get written along an x-axis. And then my y value is going to be the output. It's going to be what happens when I evaluated that sine function. So again, we want to use what we call the 5 key thetas or the 5 key radians to graphing a sine function. And that's going to be here at your initial side at pi over 2, pi, 3 pi over 2, and then back again at 2 pi. And so what this is called is one initial interval where we start and stop one rotation. All right, so it's one rotation before you continue off again. And so these are going to be my x values. And so the y value when I plot these points is going to be what happens when I evaluate sine of theta. So the y value is going to be the sine at 0. And here at 0, my sine value is 0. And so what you're really going to do is you're really going to think about these y values right here that are on our unit circle. Right? So at 0, the sine of 0 is 0. At pi over 2, sine is 1. At pi, sine is 0 again. 3 pi over 2 is -1. And at 2 pi, we're back at 0. And so what we're doing is we're taking the coordinates off of our unit circle, and we're evaluating the different radians for that particular trig function and making an in-out table to be able to plot some points. So now what we're going to do is instead of plotting them on a unit circle is we're going to make a graph. Right. And it doesn't need to be very big. Right. And so we're going to label this. This is going to be +1 and -1. And so then we need to make some tick marks for these input values. So this is going to be 0 at the origin, pi over 2, pi, 3 pi over 2, and 2 pi. So again, all of your input values, things that we consider an input, are always labeled along an x-axis. The outputs, what happens when we evaluate, are the y values. And so for our sine function, you're going to start graphing these points. You have a point here at 0, 0. At pi over 2, the coordinate is 1. At pi, I'm here at 0 again. 3 pi over 2 is down here at -1. And at 2 pi, I'm at 0. And so we want to make this a nice, smooth curve. And so that's what one full sine curve looks like. Right? And so what we have is we have key characteristics of this sine curve. We have what's called the amplitude. Right? And the amplitude in this case is just 1. It's the height from this kind of middle axis to the top of the maximum and then the minimum. So it's this distance right here. Right? That's what we consider our amplitude. And the amplitude is always a positive value. So we always want to think it's just distance, so its distance is always positive. We also have something that we call the period. Now the period is the length of this sine curve. It's how long from start to finish. And so just when we started at 0, we ended at 2 pi. That's what we call the period, which will change eventually. The domain, which is sometimes called the initial interval. All right. The initial interval is, again, I started here at 0, and so I'm going to use a little bracket to say 0 is included in my input values. And I stopped at 2 pi, and I'm going to bracket that off again. So these brackets say that you actually included these coordinates. And then the range, this is how high up and how low we went. So you always go from the lowest to the highest. So the lowest point on this graph is -1, and it goes all the way up to +1. And so these are some key characteristics of your sine function in terms of what we know about the distances and the lengths. And so when you are looking at a sine curve, there's some kind of a standard form that we used. So it's y equals a times the sine of bx plus c plus d. Right? And it looks like a lot of letters in here, but really all we're doing is we're saying the amplitude right here is the absolute value of a, right? And the period is 2 pi divided by b. And so we want to be able to start seeing like a general notation. And so again, this is going to help us find the amplitude. And so this gives us a height value. This one will help us with the length of this interval. We'll talk about what happens in these parentheses later. And then this right here gives us a vertical shift. And that's actually going to change some of our range. So let's look at a couple other sine curves, and we're going to need this chart up here. So let's graph, for example. I want to be able to graph, let's just change the amplitude. For example, let's write this as 2/3 of the sine of x. You know, sometimes, let me rewrite that. What we like to do is we like to write it as an actual equation. So let me put a y equals in front of that. Okay. And so all I'm going to do is I'm just going to put a number here in front. And so what that does is that changes the amplitude. The only thing that 2/3 will change is it will change how high up and how low this graph goes. And so what we want to do is we want to make an in-out chart for our graph. All right. So again, we're going to use those same 5 input values. 0, pi over 2, pi, 3 pi over 2, and 2 pi. And so what we're going to do is we're going to take the normal output values. So what this is saying is whatever the sine of x value is, I need to take 2/3 of that. So there's an invisible multiplication inside here. And so what this is doing is saying take 2/3 of what happened at the coordinate that was already there. All right, so on our other chart at 0, the sine of x was 0. And so now I need 2/3 times that, which is just 0. At pi over 2, look what happened at pi over 2. Originally, the value was 1. So I'm going to take 2/3 of what my original output is, which means I'm only going up 2/3 of the way high. Right? Again, we're going to use all of these output values and just change how high up they go. So at the pi, the sine of pi was 0, so I want 2/3 of 0, which is just 0. At 3 pi over 2, it was originally -1, and I want 2/3 of -1, which is -2/3. And again, at 2 pi, it was originally 0, and I want 2/3 of 0, which is, again, 0. So all of these values right here were the original output values for sine. And when you have a number on the outside like this, whatever the operation is attached to that trig function is what you're going to still do to that trig function. And so now we're going to be able to graph a sketch of what those look like. And then we'll label some information. All right. So to make this a little easier, actually, let's just leave it alone. All right, try to make your tick marks nice and evenly spaced. Otherwise, your graph will not look like a nice curve. And so I'm really going to plot the coordinate 0, 0 again. But then at pi over 2, I only want to go up 2/3 of the way, which is right about here. All right, it's not all the way up to 1, so it's about 2/3 of the way up. And then at pi, I'm back down to 0. At 3 pi over 2, I want to go 2/3 of the way down, and then back here again. And so my graph is going to look almost the exact same. The only difference is that it's a little bit lower. And so when we discuss what is our amplitude, right, our amplitude in this case now is 2/3. It's that number in front of the sine function that changes the height. Right? The period of this graph hasn't changed. It still started at 0 and went to 2 pi. Again, my domain, or my initial interval, again, started at 0, went to 2 pi. And now in this case, my range is also changing based off of this amplitude, because now the lowest that it goes is actually -2/3, and the highest it goes is +2/3. So your range is also going to change when we have a change in amplitude.